So I'm Aaron Friedman from Ansible Technology, and it's my privilege and delight to show you the model of the James Webb Space Telescope. This is a full-scale model. It's a $5 billion telescope, and it's scheduled to launch in 2014. NASA's doing the project. It's being built by Northrop Grumman, and it's designed to look at the edge of the universe, and to do that, it uses this, what will be the largest infrared mirror ever launched in space. Each one of those segments is about my height. There are 18 of them, and it's an articulated mirror. So when they get it up into space, they'll be able to very carefully focus it. Each segment is adjustable. Below it is the heat shield. Because it's an infrared telescope, it has to operate as close to absolute zero temperatures as possible, and it can never look at the sun. So the sun and the Earth will always be below the shield. The heat shield, the difference from the bottom of the shield to the top can be 500 degrees. Any solar radiation passing through each layer is reduced by 50% each time. At the bottom of the telescope, there are these thrusters. In order to keep the James Webb located at this gravity well called L2, they need to do what they call station keeping. They're always going to use a little fuel to keep this thing in the right position. Unfortunately, that means that they have a limited amount of fuel for this thing to work, which is about 10 years. Because it's 1 million miles away, we won't be able to repair it if it doesn't work or if it fails. Every piece of this has to work perfectly, otherwise it won't work at all. But they have a lot of confidence, and there's a lot of amazing people that are working very hard to test and be sure that they're doing it right. And personally, they've been here at the World Science Fair this week, and I've had a total blast talking to them and getting involved in the science and having my questions answered. And anyway, something to look forward to, 2014, and thank you very much. I'm going to answer that fourth question. It's a good question. Most of the Magellanic Clouds, by the way, they're clusters of stars, about 1 million stars, and they're the oldest stars that we can see in our Milky Way. They're very important in establishing some of the scale of distances. Now, I've never seen them. They're down in the southern hemisphere. You've got to go to Australia to see it. I didn't even realize you could look at the galaxy that way. So I have a new mission. I want to get down to Australia. Next up is this constellation Orion. Now, if we go to a traditional planetarium, they will show you Orion this way. You're now seeing the actual correct position of the stars that make Orion. It only looks like Orion if you're on Earth looking in the right direction. Here's Betelgeuse, a famous star, 522 light years away, Rigel 773. And that is the middle star of the belt of Orion. It's 1,342 light years away. Okay, so here we are. Here's our solar system. And for a variety of reasons, instead of measuring the distances in kilometers or miles, which we can do, but it's a little cumbersome, we talk about distances in astronomical units. And an astronomical unit is the distance between the sun and the Earth. We call that 1 AU. Now, our virtual spaceship, which we're flying around on here, will always tell us how far we are. Right now, from the sun, we're 1 astronomical unit. Just straighten this out. I'll go on the ecliptic. It is, and I agree, indeed.